All right, hello everyone. Welcome to the 2024 3-Minute Thesis finale. Today we have 5 finalists that are competing for first place, runner-up, and People's Choice Award. So I am Fernando. I am the 3-Minute Thesis coordinator, and I'm also a graduate specialist within the Graduate Education Office here on campus. So let's begin with what is the 3-Minute Thesis. This competition started in 2008 at the University of Queensland in Australia, and it's grown to over 900 universities, 340 being in the United States, and over 85 countries now host the 3-Minute Thesis competition. This is an opportunity for students to effectively explain their research graduate work in 3 minutes with one slide using language appropriate to a non-specialist audience. This cultivates academic, presentation, and research skills. So why compete? What is at stake for our competitors? Well, this provides the student an opportunity with a professional summary of their research, along with photos and videos, which they can use to elevate their portfolio, their website, their LinkedIn, and other professional profiles. And then we'll be awarding scholarship prizes. So first place will be awarded $500. Runner-up will be awarded $300, and People's Choice will be awarded $200. And for first place, in addition to the scholarship prize, they will be invited to represent S&T at the Midwestern Association of Graduate Schools Regional Competition. And that will be held in April 2025, I believe in Indianapolis, Indiana. So for the first place winner, there will be travel reimbursement as well. So what are the rules? A single static slide is permitted, presented from the beginning of the oration. No additional electronic media or props are permitted. Presentation are to be spoken word. Presentations have commenced when the presenter starts their presentation through movement or speech. And presentations are 3 minutes, so exceeding the 3 minutes will result in a disqualification. And then the decision of the adjudicating panel is final. All right, so the judges will make their decisions based on these criteria. So first is comprehension and content. Did the presentation provide clear motivation, background, and significance to the research question? Did the presentation clearly describe the research strategy and design and the results finding of the research? And did the presentation clearly describe the conclusions, outcomes, and impact of their research? And then also engagement and communication. Was the oration delivered clearly and the language appropriate for non-specialist audience? Was the PowerPoint slide well-defined and did it enhance the presentation? And did the presenter convey enthusiasm for their research and did they capture and maintain the audience's attention? So it's not only about their research skills, but also their presentation skills. So we want to thank our preliminary and semifinal round judges listed here. We've been through 2 rounds already, so we want to recognize the judges who helped us get to this point. They also did provide valuable feedback to our contestants in preparation for today's finale. And finally, welcome and thank you to our finale judges here that we have today. We have Cody Hans, who's Assistant Vice President of Legends Bank. John Butts, City Administrator of Rolla. Rebecca Roberts, Educational Consultant with the Regional Professional Development Center. Dr. Kate Drown, who is the Assistant Provost of Faculty Affairs, as well as Professor of English and Technical Communications. And then lastly, we have William Smith, who's Director of Inclusion and Engagement. So welcome and thank you for being here. All right, and here are our finalists today. We have Nilofar Zendadel, who is a PhD student in mechanical engineering. The name of their presentation is Beyond Words, Silent Communication with Robots. We have Mobashir Med, who is a PhD student in metallurgical engineering. And the title of his presentation is Fiber Optic Sensors in EAF Burner, Future of Temperature Sensing in Steelmaking. We have Jennifer Harrell, who's a PhD student in biological sciences, and the title of her presentation is Sleep Impacts Metabolic Processes. We have Amir Iqbal, who's a PhD student in mining engineering. And the title of his presentation is Innovative Fire Safety Strategies for Lithium-Ion Batteries in Electric Vehicles, Detection, Mitigation, and Control of Hazardous Emissions. And lastly, we have Omar Rinchi, a PhD student in computer engineering. Title of his presentation is Remote Breathing, Monitoring Using LiDAR Technology. All right, so congrats to our finalists for making it here today. Great work today. And before we begin, just want to let the audience know that after each presentation, we'll take a couple of minutes to allow the judges some time for scoring. Okay. So as we begin, we'll have Nilofar Zendendale. Again, will be presenting on Beyond Words, Silent Communication with Robots. Nilofar. You can hit next.
Hello everyone. Let me start by asking you to imagine waking up one day unable to speak or move. How would you communicate? Now picture yourself working with a robot that instantly knows what you need without any words or movements. I'm developing a system where machines interpret brainwaves and arm movements, making silent, effortless communication a reality. This technology has transformative potential. In rehabilitation, it gives people with locked-in syndrome a means to reconnect with their environment. In manufacturing, it enables robots to sense what we need without us having to ask. In noisy, fast-paced settings where speaking or gestures might fail, robots can use brainwaves or arm movements to make seamless human-like collaboration. Our eyes reveal our focus. I captured this focus not through cameras, which struggle with lighting or visibility issues, but I measure tiny electrical signals that our eyes generate as they move. The eye acts like a dipole. It has positive and negative poles. And as we shift our gaze, these poles move too. By placing electrodes around the eyes, we can measure these movements. Even better than cameras that might fail sometimes in some challenging conditions. To demonstrate the potential of eye tracking, I developed a system that lets the user control a drone by looking at the specific commands on a screen. The system detects blinks and horizontal and vertical eye movements with an error rate of less than 10%. As the user moves their gaze from one command to another, the system translates these eye movements into actions like taking off, landing, or moving or changing direction, all instantly. As the second part of my research, I focus on brainwaves, tiny electrical signals that are generated by neurons in our brain. These signals reflect our intention, whether it's physical actions or just imagining a movement. These signals reflect our intentions. And for example, if we imagine a movement, then we can predict these movements with these signals. I trained a machine learning model to detect these movements with over 90% accuracy. Thank you so much for joining me today. The future of interaction is silent. Now, how would you engage with a world where thoughts speak louder than words? Thank you.
Thank you, Nilofar. At this time, we'll give the judges a couple minutes to jot down their feedback, and we'll proceed with the next presenter. Next up, we have Mobashir Ahmed, who's, again, PhD student in metallurgical engineering, and he'll be presenting on fiber optic sensors and EAF burner, future of temperature sensing in steelmaking.
Good afternoon, everyone. Steel is the most engineered material in human history. From the car that we drive as a daily driver to spectacular structures like the Gateway Arch in St. Louis, we can see the use of steel everywhere around us. There are lots of ways to make steel. Among them, electric arc furnace steel making accounts for almost 67% of global steel making. Being a high-temperature industry, you can imagine that temperature sensing lies at the very heart of steel making. The current temperature sensing technologies like thermocouples can only provide single-point data. So, if you want to collect data points from different locations simultaneously, you need to install multiple thermocouples. That can be messy and can also compromise structural integrity, as you may need to make multiple holes to install multiple thermocouples. Furthermore, these technologies also suffer from electromagnetic interference, which is very common, especially in electric arc furnace steelmaking. So, there are unsupervised areas in the current steelmaking processes due to the limitation of existing technologies. Any thermal events occurring in these areas cannot be seen or corrected with the existing technologies. Therefore, there is a need of better temperature sensing technology for safety as well as energy optimization in the steelmaking process. My research goal is to validate the use of optical fibers for temperature monitoring in an electric arc furnace burner, because optical fiber offers a better alternative for temperature sensing. It can collect data point all along the fiber length, and it's possible to have data collection point at every 1 millimeter distance apart. Also, unlike thermocouples, optical fibers' data accuracy does not get affected by the electromagnetic interference. Currently, burner operation doesn't have any temperature monitoring system in them. On the top right corner, you can see an industrial electric arc furnace burner where we have installed optical fibers. These fibers will be used to collect temperature data during real-time steelmaking process. Based on that, we can create a thermal model of the burner and correlate the operational events with the temperature distribution. This will lead to energy optimization and also better decision making in terms of burner operation and the overall steelmaking process a lot. So this is the future of temperature sensing in steelmaking. Thank you.
Thank you. All right, and again, we'll give our judges a few minutes to score. Next up, we have Jennifer Harrell, who is a PhD student in biological sciences, and the title of her presentation is Sleep Impacts Metabolic Processes.
Hi, everyone. My name's Jennifer. Has anybody in this room ever had a bad night's sleep, or maybe stayed up too late? Yeah, all the students are raising their hands. Stayed up too late, and then you couldn't perform the next day, right? Well, I study sleep, and that's a bit of a problem because inadequate sleep has been associated with several disease states in humans. The CDC reports that 1 in 3 adults does not get adequate sleep every night, and that's a problem. So to study this problem, we use the fruit fly because what our experimental design is would be impossible in humans and mice. What we do is we take a population of fruit flies that are all the same age, and we monitor their sleep for 30 days, 24/7 for 30 days, and we gather all their sleep characteristics, such as fragmentation and how much time they sleep. We take that sleep data and then we feed it into our innovative mathematical model, and that puts our flies into 2 distinct groups. We have flies here that are projected to have a normal life, they're sleeping great, and then we have our flies here that are in our predicted short life group. And this is very intriguing to us because all the flies are the same age, however, they're aging different at a biological rate. And then what we do after this is several different biochemical and biomechanic studies. And we find out that at a molecular level, our flies are actually functioning differently. Our flies that are sleeping normally have what we expect to see in our biochemical analyses. Their protein machinery is functioning, they have enough energy to do what they need to do, the organism functions as it should be. However, in our short-lived flies, everything is haywire. Our flies can't cope with any stress. All of their molecular machinery is beginning to break down. They don't have proteins. They don't have the energy needed to make the proteins. So any sort of stress actually will kill those flies. The last two images you see on the slide, figure 6B and 6A, figure 6B is an image of what we would expect to see in a normal fly. Each one of those colors represents a different type of energy that your body needs to function, and that's the same type of energy that humans use, actually. And we expect to see what we see in 6B. We see energy localized to the regions of the abdomen where it should be. We see the types of energy we expect to see. 6A, we see no organization. We see stuff everywhere, and that's literally what the problem is. There's no organization, there's no energy, there's no protein. And if this can happen in flies using the same type of energy, it can definitely happen in humans. Thank you very much.
Thank you, Jennifer. All right, so at this time, we'll give our judges a couple of minutes. So up next, we have Amir Iqbal with his presentation titled Innovative Fire Safety Strategies for Lithium-Ion Batteries in Electric Vehicles, Detection, Mitigation, and Control of Hazardous Emissions.
So EVs are becoming the norm, and we are about to see an exponential rise in the EV sales in the next couple of years. In fact, it is predicted that by 2030, in the US market alone, we'll see EV sales of about 4.7 million units a year, compared to the 500,000 that was sold in 2021. So that's a huge rise. The aim here is to curb the greenhouse gases emission to give our future generations a sustainable environment. But there is a threat, there is a catch with the EVs. That is that they pose a certain toxic threat which we don't understand yet. So the more we have EVs on the road, the more there is a chance of one of them catching on fire. So they still do catch on fire, but since we don't have enough of them, we don't see them that much. So the problem that we have here is that the toxic threat that they emit, we don't understand it. We don't have anything, a certain extinguisher that is specific to EVs and lithium-ion batteries to effectively suppress it. And we don't also have anything, a mask or something, to protect our emergency responders from that threat. So what I'm going to do is I'm going to take those batteries, the power source of EVs, put them to test, fire them up, explode them, and study the toxic threat that they pose with their smoke, what kind of gases they emit. After that, what we're going to do is we're going to apply different kind of extinguishers to see what kind of extinguisher would effectively suppress it, put them out, so that we don't have that problem. The next thing that we're going to look into is design a mask that will protect the emergency responders that are going to be there on the first line of defense. So what that is going to do overall is increase the public health and safety and the awareness about lithium-ion battery fires and their threat, which will in turn facilitate the widespread adoption of EVs in the market, which will be helpful to give our future generations a sustainable environment. Also, what this thing is going to do, what this project or the results of this project is going to do is going to give us the public health and safety improvement, the environmental health and safety improvement, and we're going to have something to fight the threat that is posed by something in the future that we're going to get into. So people will not be afraid to get into EVs, and we will have our emergency responders equipped with the proper tools to fight them and to protect themselves from that threat. So that's what I have so far for you. Thank you so much for listening to me. Yep.
All right. Thank you, Amir. And our final finalist, we have Omar Rinchi, who will be presenting on remote breathing monitoring using LiDAR technology. Omar.
Breathing. It is the most fundamental act of life and what keeps us alive. It is important, no doubt, but what is also important is measuring and monitoring of our breathing. Think about that. Many of our beloved elderly live in senior care facilities where they undergo continuous check for their vital metrics. maybe their heart rate, maybe their blood pressure, but do they measure breathing? It is usually ignored and overlooked, although that 7% of world population suffer from breathing diseases. And one part of this problem is that the current existing breathing monitoring solutions are based on wearable devices that are not user-friendly. For example, patients need to wear these wearable devices continuously for long periods of time. We need to assign one breathing device per patient, so if we have multiple patients, we will need multiple breathing devices. Patients need to remember to wear them all the time. Patients need to remember to charge them all the time, and it can be socially awkward and non-comfy to wear them in public. Unlike the current existing monitoring technologies, in my research, I have developed a breathing monitoring technology that can measure breathing of multiple people simultaneously and 100% remotely. How does that occur? The core instrument of my solution is what is called LiDAR sensors. LiDARs are nothing but the 3D scanners that are usually used with self-driving cars. All what you need to do is to be in the line of sight of the LiDAR, and that's it. You don't need to make any interaction with the device. You don't need to learn how to use it. You don't even need to know about its existence. Just be there and breathe, and that's it. The LiDAR will make a 3D scan of you and will collect raw LiDAR data. And you can see from the data why I like LiDAR, as it can protect your privacy where no one can recognize you. Also, it can work day and night with no illumination requirement. After that, using the power of AI solution that I developed, the AI can recognize any human in that sphere and focus on their chest area. Finally, my algorithm will convert the chest movement that do natural breathing into breathing signals. My results show that using these breathing signals, we can measure different breathing metrics. For example, we can measure each time a human made a breath. We can count these breaths and divide it by unit time to find the speed of breathing. We can find the depth of the breath by looking at the amplitude of the breathing signal. And we can even find these periods of time where a human is not breathing, like in sleeping apnea, all in one solution. At the end of the day, this solution is not only about designing a capable engineering technology, but more of providing a solution that is more human-focused and designed for the users. It is designed for those that we care about, like our infants and our elderly, and I'm so excited to share my progress with you. Thank you so much.
Great job, Omar. And great job to all of our presenters. At this time, we will take a break. The judges will be deliberating and will return with results momentarily. At this time, please use this time to vote for the People's Choice Award by answering the poll or filling out the People's Choice rubric. So Sharon here will go around and pass out the People's Choice rubrics, and then for our viewers online, there will be a poll that you will vote for, your favorite finalist, and we will get back together in about 20 minutes and announce the winners. So thank you. All right. Thank you guys so much for your help, for attending and for your help deciding the People's Choice Award. And of course, thank you to our judges for that hard decision. So first off, we will start with People's Choice Award. So this year's People's Choice Award, and again, will be awarded $200, goes to Mobashir Ahmed. Do you want to hold it up for a picture? Great job, Mobashir. All right. And up next, the runner-up for the 3-minute thesis competition, and again, awarded $300. And the runner-up also will be the runner-up to the MAGS competition, the regional competition, in case first place can't make it. And so runner-up goes to Jennifer Harrell. Congrats. If you want to hold it up for a picture. All right, and finally, first place awarded $500 and will represent S&T at the regional competition in April, goes to Omar Rinchi. Congrats, Omar.
Thank you. Thank you.
All right, and this concludes our program. So thank you to our finalists for presenting today. Thank you to our judges for making that difficult decision. And lastly, thank you to our audience here in person and over Zoom. We really appreciate you attending, and this concludes our program. Thank you, guys.